Hello everyone. In this lesson, we're going to be talking about how to perform a long division and a quicker way to do it, which is a synthetic division. This is especially useful in factoring out polynomial. In combination with the rational root test, this technique enables us to factor out a polynomial even if it also has, in addition to rational roots, also has irrational roots. So if it has rational roots, we can basically use the rational root test to figure out what those roots are. In this case, we're going to actually use the same example we used in the previous lesson. So our polynomial is a fourth degree polynomial, x to the fourth minus 4x cubed minus x squared plus 16x minus 12. And we want to divide this by x minus 1 because using the rational root test, we know that this is one of the factors in this polynomial. So this is important. After you place the division sign, the long division sign, the dividend, which is essentially the numerator of the fraction, that's going to go underneath this line. So this is going to be our dividend right here. That's the dividend. And the divisor, which is the denominator of the fraction, is going to go on the left-hand side right here. So the x minus 1 is going to be the divisor. And the procedure is as follows. At all times, we're only going to look at the first term from the, what we're going to later on call the quotient. We're going to look at the first term of the dividend and the first term of the divisor. So the dividend is x to the fourth, the first term, and the divisor is x. So we always want to multiply the divisor by something that's going to give us the same exact first term in the dividend. So if I want to get x to the fourth, I'm going to have to multiply x minus 1 by x cubed. And when I do that, I get x to the fourth minus x cubed. So I'm going to multiply x cubed by x minus 1, and I'm going to put that in parentheses here, and then I'm going to subtract, as you can see here. So x to the fourth, the first term needs to cancel always, it needs to go to 0, and then I bring down the next term. So we get negative 4x cubed plus x cubed, that's negative 3x cubed. I bring down x squared here, and that's going to be negative 3x cubed minus x squared. Again, I repeat the same process. I want to multiply x minus 1, and in particular x, by something to get negative 3x squared, x cubed. And that term is going to be negative 3x squared. So I'm going to go ahead and multiply that in the second step by x minus 1. So I get negative 3x cubed plus 3x squared. And then I'm going to subtract, and I'm going to repeat this process. So after I subtract that one, the negative 3x cubed cancels. I get negative x squared minus 3x squared. That's negative 4x squared. And I bring down the next term right here. And then again, I look at this first term. So I want to multiply x minus 1 by something that is going to give me negative 4x squared. That thing is negative 4x. So I go up here, I put negative 4x here. And again, I repeat the same process. I'm going to multiply that by x minus 1. That's going to give me negative 4x squared plus 4x. And I'm going to subtract that. Then I get 12x minus, and then I get 12x. And then I bring down the last term of my quotient here, of my dividend here, right? So I'm going to go ahead and bring down that last 12 that we have. So it's a little bit, there is a reason why they call this a long division, because it's a little bit tedious and it takes a little longer because you have to write all these terms. So I bring down that 12, and the last term is going to be 12 for the quotient. Plus 12 times x minus 1 is going to give me 12x minus 2, 12, and that's going to give me a remainder of 0, which is what I expected. I expected x minus 1 to be a factor here. So the remainder is 0. And the quotient, which is circled in red here, is x cubed minus 3x squared minus 4x plus 12. Now we can do exactly the same procedure if we use synthetic division, but it's gonna be much quicker and much easier to do, basically, because all we're going to carry instead of all these x cubed and x to the fourth is just the coefficients. We're only going to carry the coefficients. The problem is we cannot always use synthetic division. So synthetic division can really be only used if dividing by, I write it right here, if dividing, I write it actually underneath there. So I'm going to go ahead and say use only if dividing by x plus or minus a. I'm going to have to fit that. All right, so let's say here. X plus or minus a. So if it's only of this form, we can use synthetic division. And what we'll do, we're going to go ahead and set that to 0 and write the root. So we have this division line. On the top, in white, we have the coefficients of our original function, of our original polynomial. So I'm talking about the fourth degree polynomial. So the coefficients are going to be 1, so right, 1, -4, -1, plus 16, and -12. So those numbers are going to be written on this very first line up here. Then for the divisor, we don't put in -1. So when it's x -1 is the factor, what goes in the synthetic division is 1. So x minus 1 equals to 0. It's the root that goes there. Now, to do a synthetic division, it's really simple. First number, first coefficient just comes directly down. So this 1 that we have here, that's going to come directly down as you see here. So that's going to go down under below this line, this big line, long line. And then after that, we start the procedure. The procedure says take this number 1 right here, multiply it by this number, and write it underneath there. So that's going to be 1 times 1, that's plus 1, and you're going to put that right underneath the -4, and you're adding these numbers. So -4 plus 1 is -3. And you repeat, -3 times 1, so 1 times -3 is -3. Again, add them, that's -4. -4 times 1 is -4. 16 minus 4 is 12. Again, the same thing. 12 times 1 is 12, and -12 plus 12, that's 0, which is the remainder. Now, what these numbers circled in blue represent, these are the coefficients of our quotient. The quotient will always be a polynomial 1 degree less than the polynomial we started with. So if you start with a polynomial of 4th degree, the quotient will be a polynomial of 3rd degree. So the 1 is going to be the coefficient for x cubed, -3 is going to be the coefficient for x squared, -4 is going to be the coefficient for x, and 12 is going to be the constant term. And this is going to give us exactly the same quotient as we found using the long division. It is shorter and faster, but it has limitations. So it has to be of this form. It has to be of the form x plus or minus a. If it's anything else, we cannot use synthetic division. We will have to use long division. So long division is definitely more generic than synthetic division. So it's really important, and it goes hand in hand with the rational root test. With the rational root test and synthetic and long division, we can factor out any polynomial that has real roots, whether it's rational or irrational, actually. I hope you enjoyed the lesson of the day and hope to see you next time. Thank you.